Hiya there guys, it's me, Mr. Minchin. Today we're ready to do some maths. This video I'm going to be talking about Thinkboards. Now Thinkboards are a really good way to show your understanding of number in a variety of different forms. Does that make sense? Is that a lot of words? A thinkboard is a way to show that you can add numbers in different ways. Does that make a bit more sense? Now I've got a maths problem here, 24 add 35. What I can do is, I've split my board into four. I've got four different ways to add these numbers. Base 10, value counters, partition, and vertical. I'm just going to run through them very quickly. Now base 10 is what we in the class call tens and ones. And I can use these are what we call concrete materials. It means I can hold on to them to help me solve this problem. 24 add 35. So to start with, I need to make 24. I take two tens, 1, 2, 3, 4 ones, 24. And it's 24 add 35. So I need to take 1, 2, 3 tens over, 1, 2, 3, 4, 5 ones over. So I've got 24 and 35. And the easiest way to add this together is to put all the tens on one side and all the ones on the other. So we've got 10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. Now, if you don't have base 10 at home, and I very much doubt you do, I don't think it's the sort of thing you asked for at Christmas time, is it? Could I get some base 10, please, Santa? Don't worry about it at all. What you can do is cut it out, okay? Cut it out with paper. Give yourself long strips for tens and little squares for ones. But there's another thing you could do if you don't have it. You can actually draw it out. So 24, to begin with, is 2 tens and 4 ones. Add 35. 1, 2, 3 tens and 5 ones. Then what I can do is add the tens. 10, 20, 30, 40, 50. Add 1, 2, 3, 4, 5, 6, 7, 8, 9. 50 add 9 is 59. So that's using base 10 to solve that problem. Another strategy we've got is value counters. Now value counters are similar to base 10, but the difference is all the counters are the same size, okay? We don't really need to show that these are tens and ones. We can just look at the number, what we call sometimes abstract. So again, if I've got 24, I can make 10, 20, and then 1, 2, 3, 4. Let me get all them all. And then I've just quickly went and put together 35. So we've got 24 add 35. And again, I can push all the tens together and all the ones together and then count it up to find the answer of 59. But again, I mean, you don't really have to make them. It does make things easier, but if not, you could just draw it with your 2 tens for 20 and 4 ones there, 3 tens for 30, 5 ones for ones. And then again, we add them all together to get our answer. So we've used concrete materials, that means hands-on materials. We've also then done them pictorially, means we've drawn them. The next step and the final step is to do what we call abstract problems. That means when we're just using the number. So we've got 24 add 35. One way to do this is to partition that number. So I can think, well, these are tens and ones. So the value of this 4 is 4. But the value of this 2 isn't 2, it's in the tens column, so it must be 20. Same here with our tens and ones. The value of this 5 is 5 because it's 5 ones. But the value in the tens column is not 3, it's tens. It's 3 tens. 10, 20, 30. So once I've got those together, I can do 30 add 20 is 50. 4 add 5 is 9. Add the 2 together, 59. And finally here, we could use a strategy that lots of people like, especially mums and dads. This is usually the only way they were really shown. When I was at school, it was the only way I was shown as well. Vertical is sometimes known as chimney sums. So we've got our tens and ones, and I would put 35 here, larger number on top, 24 underneath. Now we would begin by saying 5 ones add 4 ones. 5 add 4 is going to be 9. Then we move to the tens column. Now this isn't 3 though, we'd say it's 30 add 20. 30 add 20 is 50. So we've got 50 and 9. We add those two together and we get 59. And there we have our think board. We've used base 10, value counters, partitioning and vertical. So, are you ready for a wee challenge? This time, we've got 32 add 45. Now, I think you should pause the video here and give it a go. Can you build a think board for 32 add 45? Now, make sure you pause that video and definitely give it a go, because if not, you'll make me a very sad fox. And I'd rather be a happy fox. Oh, that was weird. Okay, have you done it? You want to see? Right, so there we are. There is my think board. The answer is 77 to that problem. Drawn it using base 10. I could have, again, used my counters. I drew it though. Value counters, again, I could have used them. I've partitioned the number here. And I've used vertical as well. Now, here's a... What? What are you laughing at? What? Oh, I have no idea what's going on today with those faces. Right, okay. If you want a wee challenge, can you make your own think board? Create a 2-digit sum. So, like 45 add 53, or 27 add 61, or whatever it is. 2-digit numbers. Can you add them together? If you could do that, could you subtract them? That means take away. Now, some of us have started looking at adding and subtracting 3-digit numbers together. I just want to quickly run through this with you. Here, I've got a 3-digit number. I've written out. We've got ones, tens, and our third digit would be hundreds. So altogether, could you say this number? It's 243. 243. Now, to draw that as base 10, using our tens and ones, hundreds, okay, come as big squares. They are 10 tens, because there's 10 tens in 100. Let me try. You're just getting a good close-up of my dog bowl there. Let me try and put this all together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that is 100 there. And you get squares of them, hundreds. So if we're to draw this as base 10, I'd have 2 hundreds, 4 tens, and 3 ones. There we go. Now, just like that here, I've got 145. 100, 4 tens, and 5 ones. Over here, I've got 312. 3 hundreds, 1 10, and 2 ones. So I've got another wee challenge for you here. I've got 4 3-digit numbers. This number here, can you say it? 216. This one here, 345. This one here, 104. There's no tens there. And over here, 551. So we've got 4 numbers. Your challenge is to draw them as if they were base 10. Pause the video, give it a go. Now, so long... Oh, for goodness sake. How am I a chicken now? Right, never mind. So long as you've paused it and you've given that a go, here's the solutions. Okay, I've had to kind of squeeze mine together. So we've got 2 hundreds, 1 10, and 6 ones for 216. Over here, I've got 3 hundreds, 4 tens, and 5 ones for 345. Down here, I've got 100, no tens, and 4 ones for 104. And over here, I've got 5 hundreds, 5 tens, and 1 1 for 551. Can you create a Thinkboard with 3-digit numbers? I've got a wee example here set up, okay, that you can pause the video and you could try this one, or you could make up your own. See how you get on. So, loads of things to try there. Hope it's something you can maybe do. You could come back to this lesson every couple of days, try another one, make up your own. And I'm just really glad I got to the end of this video without making myself look silly.